Hello students, in this video we learn out of two mm, important defects from our syllabus. Number one, Scotty defect. This defect or Scotty defect was discovered by German scientist, that is Scotty, in 1930. Simply, if an atom or ion is missing from its lattice site and the vacancy is created, then is termed as Scotty defects. Now student, see the picture. It is a crystal lattice of A plus B minus compound where they are systematic orderly arranged in a three-dimensional space, and this is the condition for ideal ionic crystal where all lattice points occupied by atoms of A plus or B minus. Now see what happened in Scotty defect. This defect occurs in ionic crystal when both cations and anion leave their sites and create two vacancies, one due to missing cation and other due to missing anion. This is the condition observed. In this defect, number of cations and anions left behind in the crystal is the same even after missing cations and anions. Therefore, crystal remains electrical neutral. Now we learn this both condition. Now students see this picture, and it is NaCl crystal lattice where each sites is occupied by Na plus and Cl minus. But student, there are two atoms are missing from the crystal lattice, that is one from missing of cation and one from missing of anion, and which create two vacancies. That vacancy is called one cation vacancy and number two anion vacancy. Now from this crystal lattice there are two ions are miss out, one Cl and one Na plus. So the student, the number of positive and negative ions are departed from the crystal. Therefore, there is no any change in electrical condition. Therefore, in this defect, crystal remains electrical neutral. So I think all of you get the what is Scotty defect. Now, student, we calculate the number of Scotty defect formed per cm cube of the crystal is given by the formula small ns is equal to capital N epsilon minus W divided by 2 RT. So we have to understand where each terms are present in this equation. Ns is nothing but the number of Scotty defect formed per cm cube of a crystal. So how much atoms or ions are departed or created a vacant space, that is indicated and S for Scotty. Capital N is equal to total number of sites per cm cube of a crystal. So how much number of sites are present in a crystal, that is capital N. W is energy required to form defects. R is a gas constant and T is a temperature. Very important students, this defect observed in that ionic compounds having high coordination number and the size of positive ions and negative ions are same or do not differ very much. Example, NaCl, KCl, KBr, etc. So students, you focus on example NaCl, KCl, KBr. Both the positive and negative ions are same size, and therefore the defect are observed these kinds of ionic crystal. Now very important fact present with this defect you have to remember. So students, the cations and anions are completely missed out from the crystal. So if you remember, if 10 atoms are present, out of that 2 atoms get departed. So it means how many atoms remaining? 8 atoms. So 100%. Due to this defect, the density of crystal decreases. So as the number of cations and anions goes on decreases, therefore the density of crystal also get decreases.